In the last lecture, we have created our first scripting file, player.jd, so our player script where we have defined process function, which is called at interval of how many frames per second we are running our game. So in my case, it was, as we noticed, was 120 FPS, so 120 times per second I'm calling this function. Okay, let's continue, and let's create a movement to the player. So we already talked about it briefly in the last lecture. Move from the script to the 2D here. So when we want to change the player position, we just need to increase the X or Y or both of them to create an illusion of the movement. Okay? So if I want to move the player here, I need to be increasing the X position. So what we could do, go back to your script, click here script. Okay, what we could do here is to change the position of the player. To access the current position of the player, you can actually use the keyword self, and you will see all the properties you have available on the player. One of them should be self position, and that's the current position of the player. If you will debug log it, so we will write here print here and in the brackets self position, you will see that's the current position of the player. So when I will run this Control B or Command B, you'll see it will be actually in this case 2 and -2. Why is actually that? Why is 2 and -2? In the end, our player has a 0, 0 as you see here. Okay, so why it's 2 and -2? Because when you will go to your play scene, so go to play scene, you see the player, I will select the player here and I click here transform. You see in my play scene, my position of the player is 2 and -2. That's why you see 2 and -2 here. So yeah. And we have executed our code from this play scene. When I press Control B, I'm executing the play scene. Okay. If I would press Control R or Command R to execute the current scene, so when I will go to the player, I'll click on the player here. Okay, the player is selected. I'm in the player scene, and I will press the Control R or Command R to run the current scene. It's a 0, 0. Okay. So actually, let's do it from the play scene because we are used to it. Command B, Control B. So I'll go to the play scene. I will change the player location. We can go to the 2D view. Click here. We can go to the 0, 0, 0, 0. When I'll press the Command B, okay, it's a 0, 0. Okay? So now I want to move the player. So what we can do, go back to where I'm going. Back to script here. And now self.position. By the way, you don't need to use the self. Self will be provided by default. You can just write it simply as a position. Okay, and this will be the same thing. But explicitly, if you want, you can just write it as self, so you know that's a property of this node. Okay, so that will be the 0, 0. And that's a vector, actually. You can see when you will hover over, position is in the format of the vector. And vectors looks like this. Vector 2 has 2 values. First is the X value, and the second one is Y value. Our player is that the vector 2 has a vector 2 value of 0, 0. So if you want to move the player right side, we need to increase the X. So we need to access this vector X and we need to increase it by some value. Okay, so we'll do it self position and plus and vector 2 and here 10, 0, like this. We actually don't need semicolons in the end. I will not be using them. And I'm just adding these two together. So we need to do it like this. We need to assign this new position to the self position. So self position equal the current position 0, 0 plus 10, 0. So if you have a position 0, 0 position and you will increase it by 10, 0 position, you will assign it here. So what will be your next position? The next position will be 10, 0. And as I told you, this will be executed 120 times per second. So this will be first call of this, the second call of this, and it will go here a second time. The position is already incremented. So the current position of the player will be 10, 0 plus 10, 0 is 20, 0. On the next call of this call, we'll get a 20, 0 plus 10, 0 again, because it is not changing, and our position will be 30, 0, and so on and so on. But here you can also see the problem, because each computer, each machine is running different FPS, right? My machine can run 120 FPS. Your machine can run 60 FPS. So in this case, when my machine is running 120 FPS, this function will be called 120 times per second. So I will change this position, x position, a lot. I will be increasing the x position by 10, 120 times per second. So I will change the x in 1 second. I will go to 120, if it's called 120 times, multiplied by 10. So I will go to 1210 position. But if you're running your code 60 times per second, this is called only 60 times per second. So in 1 second, you will move. So if you're moving 10 pixels multiplied by 60, so this you will just move 600 x on the end x position. So see, now on each machine, this will be running. Your game will be running differently. On faster machines, you will be playing your game faster. On the slower machines, you will be playing your game slower. It doesn't make sense. So here comes the delta. We can do something with the delta to make it so it's running on each machine the same. But first, let's execute it like this, because you will see the player will be moving extremely fast. This code is executed 120 times per second, so I will just run this and I will be moving away immediately. You saw the player, he just ran away, like this. So you want to slow it down. What we can do is this position 10 and 0, we can multiply it by delta. What it will do, you see there's some small number, there's 0.008 in my case. So if I will multiply 10 by 0.008, this will make the value much smaller. So the increment changes will be adjusted to your FPS rate. Okay, so that's a common practice. You will see it in Unreal Engine, in Unity, in Godot. If you want to make frame-independent movement, then you need to multiply your values by the delta in this update or process functions. Okay, so now in my case, I will be multiplied by the 0.008. In your case, if you are running 60 FPS, you will be multiplied by 0.016, and this will create the same movement at each machine. Okay, so now let's save it and run it. Now it looks like more like a nice movement. And if I would want to move also diagonally, so I can move the 10-10. So this will be diagonal movement because I'm going the 10 pixels, you can see, and the 10 pixels at the same time, right and down. Okay, if I will increase that x, I'll be moving faster to the right side. Okay, so that's how we can create a movement. Also, we can try to maybe, if you want to comment the code, by the way, just go at the beginning of the line and press Ctrl or Command and backslash to comment it out, so the code will be not executed. And we can access here self position x, and we can plus equal 20, multiply it by delta. So I'm just changing the x position in this case. Okay, so when I will run it, we'll be moving by x by 20. Okay, so that's the same basically. And also this code, we can write self position equals self position plus. We can just get rid of this part and plus equal, and this is the same. This means that self position plus self position, if it's plus equal. And here is the same, self position x plus self position x plus 20 multiplied by delta. Okay, so that's how I can change the position. So I can here, I can be changing self position y by minus 20 and delta and run this and moving up. Okay, so that's how it works. At each of the second, I will change the position. I will change the position x. So if the x is currently 0, I will increase it by the 20 multiplied by 0.008, right? So at each frame, how much is 20 by 0.008 actually? So we are going with a 20 multiplied by 0.008. Okay, so at each call of this function, I will change my position by 0.16 pixels. Okay, but this is happening very quickly, right? So as I told you, this process function is called, in my case, 100 times per second, 120 times per second. So this will happen 120 times per second, this change. How big will be the change, right? So it will be multiplied by 120 times per second. So I will go basically to the position 20 in 1 second. All right, so if we can see it in I'll just remove this. I will write here print and self position x. Okay, and I will run this, and you will see in 1 second I will be around 20 position, 20 pixels. Yeah, it's happening very fast, but at 1 second I'm around 20 pixels in my grid, the position 20, 0. Okay, so that's how you can change the position. Either do this if you want to change the two positions at the same time, or you can just access the self position and separately access the X and the Y and change them. And this is manipulating what you're accessing with the self position. Here, self position, you're manipulating this here position, and you are changing this during your play as you're playing the game. You have access to these properties. You can change them, and this created this movement. The same will be applied with the rotation and scale. If you want to change these values, of course you can, and it will be oops, what I did. Okay, so the same, we can access here self rotation, not rotate, but the rotation, and we can change the rotation plus equal 10 multiplied by the delta, and we also can access self scale and multiply it plus equal vector 2, because scale has the X and Y positions you see here. So vector 2, change the scale by, let's say, 0.2 and 0.2, and multiply it by the delta, like this. Okay, so we can change multiple things at the same time. Let's execute it, and ooh, okay, my player is flying in space and it's moving closer to the camera. For example, that would be the effect I would be maybe going for, maybe 0.4, 0.4, and a player has been shot to the space. Okay. Okay, that's it, guys. So that's how you can change the positions and rotation and the scale, and you can access all of this actually. What you see on the right side, and you see all these properties here. Oops, these properties here. When you write a self keyword, you can access all of them here with a self. Okay, and you can change and manipulate them. Okay, this should be 0.4, right? Save this, and in the next lecture, we'll create a movement where we actually hold the keys on the keyboard and we are moving not only these hard-coded positions, but as we are pressing the up arrow, we are moving up. Okay, so for this, I will see you next one. Cheers.